Hi, a very good evening to all of you. By now, all of you here who are present have completed few projects. You have tried many different things. So this particular Shiny app is a web framework which is used along with R, and some of you have already created few projects in it. We have also published few of your projects. People who are, participants who are doing cast level 2 and 3. Some of these projects are published as well in one of the portal. I'll share the link of portal today, or I think I've already done in the group just before this session. You can check it in the group. It is r.actuarylife.com, which is a portal to publish Shiny apps or any other R code that you want to do. So we have provisioned our studio server and a Shiny server on that machine, which is available for all of you to publish your projects, which could be any Shiny app project or it could be our project as well. So, as the name suggests, it is a calculator that we want to make using R and Shiny package. And as I said, Shiny is a web framework available in R Studio. It is made by the producers of R Studio, the same company. And there is a free version available for Shiny, both for individual work and for commercial work. However, they also offer more sophisticated versions of Shiny with more provisions for commercial work, and organizations do subscribe to it to make some automated apps which can work in intranet or on public internet to do certain work. Quite useful framework because it helps to integrate what you're doing in R as a backend with something like HTML or JavaScript. However, even if you don't use Shiny, it is quite possible to link R with, say, a PHP page or a website or a web application. Shiny just does the work quite smoothly and without the hassle of running the API on your own. So it is always advisable to use a work like Django or similar other frameworks for different languages because there could be a learning curve with them. But once you learn it, you actually save a lot of man hours if you are using similar kind of application development over and over again. So the objective of including this into our cast is because one of our focus is also to help the participants and aspiring actuaries understand the importance of web application, because we believe that future is about running all these applications in a browser environment. Need not be a Chrome browser or an internet browser. It could be any application which runs off the internet, which resides in the cloud and can be called in any device, including including PCs or mobile devices. And that's one reason why this web-based annuity calculator using R and Shiny is included here. We also have another application at level 3, which would be made using Shiny. So I think for those who have never done any web scripting before or have never made any application apart from working in Excel, this is a good opportunity for you to learn about how to use APIs, how to use functions, call them in, or make more than one file for the same program, run them together, and how to visualize what you want to input or output. So Shiny is a very good example of that, and we have already included this in cast level 2. So the project was pretty simple, that you have to use R and Shiny package, and you have to allow user to input interest rate, mortality, and then you have to calculate the APV. And the output was a working Shiny application built in. So if we look at how Shiny is working, so all you need to do is install the Shiny package. That's the first step, of course. So when you work with Shiny, you have to ensure that the package is installed in your R environment. So as you can see in this R Studio, all you have to do is just do that install Shiny and then install packages Shiny, and it will start working. So it's a package, like any other package that we have in our environment. This is also a package, and we can use Shiny to build application, just out of the box. And I believe I have already installed it here, so it would be visible. So you can see here, this is web application framework for R. So I'm hoping all of you who are present here in the class, you have already installed Shiny on your machine. And if you have not done that, of course, it is, as I said, like any other package, and you can just do install.packages and it would just be available. Now, it is a big package because it actually does a lot of work in terms of UI development, which is user interface, and in terms of spaces where you can display your output. It can also integrate with other applications. It can allow you to interact with the user's browser through JavaScript. So you can ask input which is beyond Shiny app. You can embed your Shiny app in one of the page. So I think I would love to take this opportunity to show some of the work that students have already done. This will give you an idea. So I highly recommend that you go to this website called as r.actuarylife.com, and here you would see some of the annuity calculators which are already made. So these are students of CAST who have done it. So if I pick up this calculator made by Mayank, what you see on the screen right now is an embed version of the calculator. So here he allows you to browse, upload the mortality file, and then identify how the mortality file is to be read, whether it has a header, whether semicolons are there. So I would say this is little complex, in comparison to what is being asked. Even if you just use a slider input, which I'm going to show you in a moment, how slider inputs work, and then display the output on the right side or somewhere on the screen is more than sufficient. So as I said, one of the biggest advantage with Shiny is that you can embed it into any web page. So if I look at the source of this particular page, that Shiny app is this this small code, which is being this annuity calculator app. So if I also call it directly into the browser, it would still work. This file, this page, right? So if I call it directly, you can see that now only app would be visible. In fact, we have made a link on all the pages where it says click here to open the app in a new window. So you can see how the app looks like. If you go to another application made by one more student, this is just to give you an idea, what you're supposed to be making. And we are fortunate that we already have some of the apps made, so we can look at them. And these people are the first ones who made the calculator. For example, Ria Garg has made this annuity calculator where we have slider inputs. So we can change the rate of interest. We can choose the type of annuity, the amount of annuity. And she also made possible to choose the tables. Which table are we using, the mortality tables. Then if it is a joint life, then age of annuitant, then male or female annuitant life, age. So these are some possibilities that we can think of. And even if you come up with a basic calculator to begin with, you can always go and you can work on the advanced version of it. You can go ahead and make advanced version and modify it. I think Ria Singla, who is there in the class also, she is working on more complex version of the same annuity calculator. So it all depends upon how you visualize the problem. And this is something which is an example of how this can be used practically. Now, we have similar illustrations, similar applications at workplace. When you go and work for an insurance company, there will be similar macros available with you, made by the actuarial team, your colleagues, or maybe with help of the IT company. And then consider this: you are working in, say, Max Life Insurance Company, and You are part of their actuarial team. You have been asked to work on the new product, and then the HO wants, the product team wants the illustration to be available on the website, so that people who are, or agent who are giving the illustration, they should be able to explain the benefits in real time by changing the variables. This is one great example of that. This could be, we have made it for annuity calculator, but this could be a participating product, or a term insurance with waiver of premium or return of premium. So the options are endless. Then once you start working towards it, once you start visualizing what all is possible, how we can use this in real scenario, and what are the options that we can work with, then it all starts making more practical sense in businesses. So this is just the beginning, where you use a piece of software, a package available, to make something which could be used to estimate the EPV of annuity. But of course, the applications are far beyond this simple calculator that we are talking about. Since this is a learning opportunity for us, so we want to ensure that we keep it as basic as possible, but also allow all of you to use your imagination and create whatever you can. So let's go back to our studio, and I'll show you how you can start a Shiny application, and how you can work with a Shiny application to create something as basic as a slider input and showing the output. But then you'll have to go forward, and you'll have to look at the possible input options, use them, and identify what kind of input is possible to to be included in your calculator, and then work with it. So to start, once the Shiny app is installed, to start a Shiny app, just go to File, click on New File, and a Shiny web app. There is a option here. So this is possible once you install the package. I have already done it, so it shows me the option to install the, or to start a new project or new file as Shiny web app. Once I do that, it shows me this input box, this dialog box, where it asks me to give a name to the application, and option to choose single file or multiple file, and then where I want to install it. Now here it could be any name to work with. Of course, it will make either single file or multiple file, and if you choose a single file, that does not mean it is any different from the multiple file scenario. As you can see here, and I'm sure you can appreciate and identify that this is UI.R in the multiple file scenario, and server.R, which indicates a front end and back end. So in UI.R, whatever is visible to the end user is going to be coded. Server.R is the back end file, where we put our code so that whatever has been inputted can be executed, and output can be computed and sent to the UI. So I suggest you work with a single file, because this is the first project. It is easy to manage. I'll give it a name. Let's call it test1, and I can choose any directory. So let me put it in where I usually put the cast projects. Where are my R projects? Okay, here we go. Okay, let's put it here. So it goes into my Google Drive, R projects cast, and I create this. So once I create, it actually copies some code over here. So as you can see, this basically, and this is a ready to go application. So as you can see, this is an application to plot some histogram, I believe. Yes, a histogram. So important thing is to understand the parts of this application. So I'm just skipping these comments. The first thing is to call the library, of course, and this is a single file app.r in which we are working. You create the UI. So this function here, fluid page, this could be anything. This need not be fluid page. This could be any other function also. What we are doing here is we are creating few options, and here because we have called we have used a slider input here. You can see this sidebar layout is the class to ensure whether we would have a sidebar or not. what does side panel would have? So these are the options that slide panel would have. There's a main panel. So you will have to study about these possible layouts. I have shared a link today in which you can see how we can install Shiny, and then further how we can use different options available in the latest version of Shiny package. If you go to that link, you would find how an application can be started. And this is one basic example that comes up when you start with a Shiny app. So once you run this, uh, and you must be wondering what are the meanings of this. So sidebar layout is the layout of the page. Sidebar panel is the panel on the left side, the content of it. So it has to be enclosed within a class called sidebar panel. Then there is a main panel, which is 2/3 of the page, which is on the right side. And this plot output is a custom function that we have created, which is referenced in the server part, server logic of the file. And so we call plot output with this plot keyword. And in the server file, in the server part, where we have this function, which is basically to render a plot with the values which are being passed. So this output with a dollar, this plot, this is basically that function that we are passing on to the argument or parameter that we are passing on to the function. So input and output, these are like standard keywords or arguments that we have in the server function. And then what you see below is nothing new for you. This is how you create a histogram in R. And this hist command is the standard command that we have. We create the bins and we create the X values. And once we have these values passed on to the histogram function, a beautiful histogram would come up. And as you can see, this bins here is a variable which is being called here. You can see this bins. So whatever value we input there, it is being passed on to how many breaks we would have, and then things like the minimum and maximum value of the bins that we have. So this bins is the variable here bins, but that input bins is what is being referenced to this slider input bins. So a name of the input, what does it do? A label, minimum maximum value, and the default value that it would have. What we are seeing right now is one of the most basic application that we can write in Shiny in order to use a slider input to draw the bins. So important thing to consider here is how this is running. So it needs a server to run. That means when you execute a Shiny app file, it uses localhost, which is at IP 127.0.0.1, and a random port, which in this case, as you can see, is 3515. Now, each time you run a Shiny app using RStudio, it would invoke a port, and on that port, the application would display. Essentially, this is a HTML code that Shiny has generated. If I open it in browser, suppose here, this is the application that, as you can see, it is localhost 127.0.0.1. This is the kind of fixed address of your localhost, and 3515 is the port number. If I go to the source of this and try to see what is in the background, whatever we have written in that app.r file is being rendered as HTML using the Shiny package. So all this code is kind of redundant, which you don't need to write. This is something which Shiny is doing for you. So if you look at it, this JSON min.js file you never included, but it has come. Shiny.css has come. So any styling, any JavaScript that you need for your application to run is being called by Shiny already. So it generates a web page for you by default. And because we chose a fluid layout, you can see this container.fluid has come. So this is a class, HTML class, which is already generated through Shiny. And only thing that our R code is doing is to basically create a form, which is here. So whatever name you gave for your input, is being used here. As you can see, this HTML code input class, and ID is same ID which you have used. Name is same name that you have used. So name would also be there. No, name field is not used. That's okay because ID bins is sufficient. And you can see the minimum value, maximum value that you gave is also come. So automatically, Shiny has converted your R code into something which is an HTML code, and it is displaying it for you. Then there is a class here. So what I'm trying to say, if you're using R, you need not learn all this HTML at all. Shiny package is doing this for you. All you need to do is just learn how to use various inputs and display output using Shiny commands. And all that you need to know is what are different inputs and what are different output possibilities we have in Shiny. All right. So this is, of course, what we have seen here is a basic app. What we have seen here is a basic app, but this can surely be complicated by including different types of input. Now that input you will have to learn how to include. For example, if we want to have another type of input here, suppose. So if we go to that reference, which I have shared with you earlier, this is the link which I have already shared in the group with all of you. So you can, and then we can search for various input possibilities here. So UI inputs, there is a whole section as you can see. So these are the UI inputs possible. These are the different types of input that you can take. Now let us have a text input. So I'll use this text input here, and let's use the exact same command. So we had a slider input earlier, right? Let me change this to a text input. So this input ID is something that you'll have to give. Let's call it ABC. A label is needed. So let's say this label is nothing but the interest rate. Let's call it also int rate. And let's write this label as interest rate. So a possible value, the default value if we want to give, we can give that over here. Suppose I give the default value as 4%. So 0.04. I can give a placeholder also if you want people to understand what is to be done with this input. So I can write enter interest rate. And then this will give me, a text input on the page. Let's see if this works. You see this, a new input has come with a default value of interest rate being 0.04. Now, this is an input value which we have, which can be also used in the server block. So, for example, here we had this input bins. Let's call a new variable and let's call it int rate. And this int rate now is what we have already inputted there as. So this input, which is, we already had a variable called input rate there, right? So that means this int rate now can be used in order to, we can include this in our calculation. And of course, in this particular program, all we can do is possibly, add or multiply this. But okay, let's do this here. I'm just trying to show you how we can use some input and use it with our calculation. So I'll just multiply this with the int rate that we have. Let's see if this works. So possibly our bins will become very small. Okay, it is non-numeric argument. We'll have to use it as numeric and then it would work. That's one explanation for the error that we have. But I think you may have got the idea what I'm trying to say. You have the possibility to get different inputs, based on your requirement and then use it in your calculation. That means Your annuity calculation would go into the server logic part. So you know how to calculate an annuity. You have done this before while making the VBA calculator as well. So that calculation goes into the server logic part. So you ask user to input various values like interest rate, which mortality to take, or what is the age, what kind of annuity would it be. So you can use a drop down for that, and then whatever input has been received, use those values to calculate an output and display your final answer. The structure of the program, at least for the annuity calculator, would remain same, more like what this sample application is. I've also shared a similar sample application in the LinkedIn group today. You can have a look at that to get an idea how the structure of program would look like. But in any case, when you start with when you start with a new Shiny app, you would also have the sample application in front of you. So you'll have to use your imagination and tweak the input, work with. So there is some error trial involved here, and I would highly encourage all of you to do that, because unless you try on your own, unless you try various input possibilities and see what it does on the screen, you are not going to learn. If I give you a solution, this is how it would work, then that would deceive the whole purpose of what we are trying to do here. We encourage you to go to the file, look at the references, think of what is possible best input for the annuity calculator, use it here, and then try to make the calculator. So as an output, what you need to do is send me this app.r file, and I would be really happy to see if you go beyond AM92 and use more than one mortality table, or something like what Mayank did, where you can input your own mortality data. So all these are always welcome, these tweaks that you can do. But even if you just make a simple annuity calculator, we are more than happy to just see that jump start and give you that jump start to then think further to make more complex programs on Shiny. So this is introduction of Shiny package and how to use it. And if you have any questions now, I would take them and try to answer all of them. Please feel free to ask anything.